Hi, today we're looking at section 7-6, polynomials. So again, take something out to take notes on. Pause the video at any time to write your notes or go back to look at prior concepts and complete the check it out problems after each of the examples on your worksheet. We have two learning targets today. First one, I can classify polynomials and write polynomials in standard form, and I can evaluate polynomial expressions. Up to this point, we've been dealing with exponents, but now we're moving on to polynomials. So first, a monomial, notice the prefix mono, is a number, a variable, or a product of numbers and variables with whole number exponents. So it's a single term, 5x negative 7 times x times y, or 0.5x to the fourth. Those are all just one term, and they're whole number exponents. These are not monomials because, for this case, we have a negative exponent. Here we have a difference, 4x minus y. And here we also will have a negative exponent when it moves up to the numerator. We're looking at degrees. For a degree of a monomial, it's a sum of the exponents of the variables. And a constant has a degree of 0. So here, this would have a degree of 0, degree of 1. This would have a 1 and 1, so a degree of 2, and this one would be a degree of 4. So let's look at some of those now. So for this first example, we want to find the degree of each monomial. Again, notice these are all products. So this is degree 0, so we're going to get 0 plus 4 plus 3, which is a degree of 7. For the next one, this is a degree of 0 and 1, so we're going to end up with a degree of 2. We just add our exponents. And here this has 0 exponent, and so the degree is going to be 0. So we have 0 degree, this is a second degree or quadratic, or second degree, I'm sorry, and degree 7. So here's your first check it out. Again, these are all monomials. This will have exponent of 1 and a 1, and this is a 0. So you just add the exponents, and that will give you your degree. Now a polynomial, notice the prefix poly is a monomial or a sum or difference of monomials. So it's one or more monomials. Degree of a polynomial is a degree of the term with the greatest degree. So you're looking at each of the individual monomials, and the one with the greatest degree will be your degree for the overall polynomial. So for these examples, we want to find the degree. So we have 11x to the 7th plus 3x cubed. So for this one, this has a degree of 7, and this monomial has a degree of 3. So the polynomial will have a degree, have the greatest degree, which would be degree of 7. Looking at our next example, we have 1/3 w squared z plus 1/2 z to the fourth minus 5. So this term here has a degree of 3. This term here has a degree of 4. And this degree here is a degree of 0. So we're looking for our highest degree, which is going to be our degree of 4. So that polynomial has a degree 4. So again, you're looking for the ones that have the monomial with the largest degree or highest degree. Here's your turn to find the degree for each polynomial. Now for standard form of polynomial, that contains one variable is written with the terms in order from the greatest degree to the least degree. And some of you have asked about this in prior classes. So they go from the largest degree to the smallest degree. When written in standard form, the coefficient of the first term is called the leading coefficient. So the leading coefficient is the coefficient in front of the monomial with the greatest degree. So we want to write the polynomials in standard form and then give the leading coefficient. So standard form we're looking for with the largest degree. So let's figure out the degree. This is degree 1, this will be degree 5, this is degree 2, and this is degree 0. So these are our degrees. So our largest degree is going to be this term, which is negative 7x to the 5th, Our next term would be our 4x squared plus 6x plus 9. And so now our leading coefficient is going to be -7. It's going to be the term, the coefficient in front of our largest degree, the first term, when written in standard form. Our next one, we have, this is degree 2, degree 6, and degree 1. So it'd be y to the 6th plus y squared minus 3y. Now our leading coefficient, keep in mind there's an implied 1 there. So our leading coefficient is 1 because it matches that one up in front of our largest degree. So here are 2 examples, 2 check-it-outs for you to do, and bring any questions you have to class. Again, you want to write these in standard form and name the leading coefficient or state the leading coefficient. Here are some terms that we use when we talk about degree. Degree 0 is a constant, that's just a number. Then we can move on to degree 1 was our linear, we've covered those. Degree 2 is our quadratic, degree 3 is a cubic, 4 is quadric, and you can go on from there. So those are degrees. You need to know at least up through the quintic. Constant, you should know degrees 0 through 5. The terms, when only one term is monomial, 2 terms is binomial, 3 terms tri, 4 more is just a poly. And one way to remember all these is just look at the prefix. Tri is 3, bi is 2, mono is 1. So you can classify a polynomial based on its degree and name. So here, which is what we want to do, classify each polynomial according to its degree and the number of terms it has. So here we have, this one's going to have degree 3, and it has 2 terms. So this one's going to be classified as a cubic binomial. So you're going to be picking one from each of these 2 columns. Pick one degree from here and the name of it from there, or the name based on the degree, and match it up. For the next one, our largest degree here is going to be degree 6, which happens to be this term here. And we have 4 terms. So this one is going to be a 6th degree polynomial. And our last example. This one we have degree 1 and 1 term. So degree 1 and 1 term makes it a linear monomial. So again, remember, you're going to be picking, based on the degree, which name it's going to hit in this column over here, and then based on the number of terms, which one's going to hit over there. So here's your check it out to do. Bring any questions to class. And our last example. A tourist accidentally drops her lip balm off the Golden Gate Bridge. The bridge is 220 feet from the water of the bay. The height of the lip balm is given by the polynomial 16t squared plus 220, where t is a time in seconds. How far above the water will the lip balm be after 3 seconds? So we're going to use this equation, or this expression we're given here. We're told t is 3. So we know t equals 3, so it's going to be 16 times 3 squared plus 220. So 16 times 9 plus 220. 16 times 9. Oh, but we are falling, so it's going to be, should be a negative there. I forgot the negative here. Follows on to down here. So we're going to end up with negative 144 plus 220, which is going to give us 76. So she'll be, her lip balm will be 76 feet above the water after 3 seconds. And again, the negative sign didn't carry over. So here is your check it out to do. And you're given another polynomial here. And you're given the time of 5 seconds. So you plug 5 in for t and see where it's going to be. So to summarize, polynomial degree is the highest degree of a monomial.